Good evening. So what we made for our DS project is a movie recommender system, which is based on the concept of cosine similarity. So what this model basically does is takes a movie name as an input from the user and recommends other movies based on certain criteria like genre and year, etc. So here is our collab file. We have imported the necessary modules like NumPy and Pandas. Here we have imported the important files like movies.csv, credits.csv, which contain necessary information about certain movies. Then we have started with the data pre-processing part. Here we got to know that what is the shape of movies data frame? That is 4803 into 20. That means it has 4803 rows and 20 columns. So in this line, we have merged the movies and credits data frame into one data frame based on the title. So it is basically kind of inner join between two tables based on title column. To get idea about the movies data frame, we have displayed the first three rows of movies data frame. Here is a snapshot. By again getting to know about the shape of the movies data frame, it has been updated to 4809 rows and 23 columns. So, this movies.info gives information about all the columns that is present in movies data frame and certain description of that column, like what is its type, what values does it hold. Then we have selected certain important columns from movies data frame like movie ID, title, overview, genre, keywords, cast, and crew. So our movies data frame now looks like this. Then we saw movies crew 0. That means movies and crew column. Then we got to know about the columns that have null values. So this is the function that we use. Then this function what it does is remove all the rows that have null values. So over to my partner for explaining the rest of the code. Thank you.
Now we have imported the AST that is used to parse and modify the source code. Now we will define a function named converter, which will be used to append in the list that we have created. We would be appending all the dictionaries that would be containing the key name, and we would be using this function on the feature genre where we would be applying this converter, and after applying this would be the product. And now we would be applying the same function on the feature keywords here, which would convert our dataset from this to this. And now in the part of pre-processing, we saw that in the cast feature it was all mixed up. So now in this function converter cast, we would be parsing through the input parameter text, and we would be minimizing the values that are put in the key name. If we would be applying a counter, if it would be less than 3, we would be appending in the list and returning that list, otherwise we would break from it. And now we would apply this function on the feature cast, and this is how it turns out to be. Now we saw that in the crew feature there was again very big mix-up, so we did processing on that. We wanted to extract only the name of the director that would be representing the crew, so we apply another function named fetch director, which would again be parsing through the parameter text. And if the job, that is the key, would be equal to director, then we would be appending that in the list. And after applying this to the crew feature, this is how it turns out to be. Now we on the overview feature we apply the split function that would be splitting it into the list of words. Now we define a collapse function that would be removing the spaces between or the list of words that we just created using the split function. We apply this collapse function on these many features, and this is how it turns out to be. Now we created another what we call feature using all the other features that we had, and that would be converted into the tags feature. Now we drop all the features that we just concatenated, and this is how it would turn out to be. Now this is the new data frame that we just created, and now we would be applying a join function on this new data frame, and this is how it would turn out to be. After applying the join function, we would also apply a lower function that would be used for further data preprocessing. Thank you.
Hi everyone. Now that we have tags column ready for each movie, let's improve our tag data using NLP. Starting with stemming. We use stemming with NLTK's Porter stemmer. It reduces words like acting, actor to their common root act. This helps us clean the tag data and group similar words together. Now we use count vectorizer to convert clean text into numerical vectors. Each movie becomes a vector of word counts, ignoring common words like the or and. This gives us a bag of words representation ready for comparison. Now we calculated cosine similarity between all movies. This gives us a matrix where each value tells us how similar two movies are. We use this in our recommend function to return top 5 similar movies for any output. We use this in our recommend function to return top 5 similar movies for any output. To avoid recomputing everything, we saved processed movie data and similarity matrix using pickle. This makes our app fast and ready to deploy. Now let's look at how we tied everything together using Flask in app.py. We loaded the pickle files and reused recommend function. The main page lets user select a movie and Flask shows the recommendations instantly. So with just two routes, one to load homepage and one to return recommendations, we created a lightweight web app that gives movie suggestions based on genres and plots. In summary, our project uses NLP for tag processing, vectorization for feature encoding, cosine similarity for ranking, and Flask for user interaction, all working together to recommend movies in real time. Thanks for watching.
So this is our final demo of our movie recommender project. We have used Streamlit platform, which is a Python framework that helps us build websites without the use of languages like HTML, CSS, and JavaScript. So it is a simple website. It displays our title, movie recommender, and then it gives the user an input option where we can input any movie that is in the file given. So when we click on the search option, it displays 4 similar movies based on our model. Thank you.